In 2017, measurements by the company Lonza in Switzerland revealed that one of their factories was emitting large amounts of a very potent greenhouse gas. This factory was producing niacin, or vitamin B3, which is a common food additive and which you may know, for example, because it is commonly added to energy drinks. These emissions discovered there were so high that they amounted to around 1% of the emissions of the whole country of Switzerland. So this was very significant, and these emissions were essentially unknown and discovered by accident. This factory was emitting a gas known as nitrous oxide, or N2O, and this is the third most important greenhouse gas after carbon dioxide and methane. N2O is a very potent greenhouse gas, meaning if you emit N2O, it has a much larger effect than emitting the same amount of CO2. If you emit 1 ton of N2O, it has the same effect as emitting around 270 tons of CO2, which is also called the global warming potential. That means even emitting very small amounts of this gas can have a very large effect. N2O is also known as laughing gas because if you inhale it, you get a funny voice, and some people use that as a party trick. And apparently it also has some popularity as a drug. I would not recommend that because it comes with some health risks, but this is not the topic of this video. N2O emissions are caused by a variety of human activities. It's, for example, emitted in agriculture, it's emitted by wastewater treatment plants, and it is emitted in the chemical industry. I want to focus on the latter, the chemical industry, because there are relatively large concentrated emission sources, which provides an opportunity to do something about it. There are 3 chemicals that are the main causes of N2O emissions in the chemical industry. The most important one is nitric acid, which is used to produce fertilizers. The other 2 are adipic acid and caprolactam, which are both used to produce synthetic fibers and certain types of plastics. N2O is, as you may guess from the chemical formula, a molecule that is composed of nitrogen and oxygen. This provides an opportunity because if we can break these molecules up, we get 2 gases, nitrogen and oxygen, that are already the main component of our atmosphere and that are completely harmless. Doing this is possible, for example, with a chemical catalyst. The good thing about it is that this is very cheap. Avoiding N2O emissions, if they come from a concentrated emission source, it's a different story if you have something like agriculture, but if they come from a concentrated emission source, avoiding these emissions is extremely cheap. It costs between 1 and 3 euros per ton of CO2 equivalent, meaning the amount of N2O that has the same effect as 1 ton of CO2. Just for comparison, in other clean tech sectors, like when we talk about hydrogen or carbon capture and storage, we often easily talk about several hundreds of euros per ton of CO2 avoided. In comparison, this is really low-hanging fruit of emission avoidance. Unfortunately, even though it's so cheap, it is not always standard practice. It is being done at many factories, but not everywhere. Within the European Union, we have something called the emission trading system, which is a cornerstone of European climate policy, and which in essence is based on the idea that companies that emit greenhouse gases have to pay for it. Now the details are complicated, there are many exceptions, they often get these emission certificates for free, but in principle that's the idea. This graphic, I think, shows how effective that can be, particularly if you have something where it's relatively easy to avoid emissions. This shows the emissions from nitric acid production, which is, as I mentioned earlier, the most important source of N2O emissions in the chemical industry. Nitric acid is something used to make fertilizers. The blue line you can see here are the emissions from the European Union. As you can see, around the year 2008, this emission curve goes down very, very rapidly. And this was not due to deindustrialization or companies shutting down. This was just because they installed technology to avoid these emissions. And that happened because initially some countries were introducing national laws to regulate these emissions, and later they were also added to the European emission trading system. Given that it's so cheap to avoid these emissions, it made sense for companies to avoid the emissions and not buy emission certificates for them. There's something that is unexpected maybe. The way N2O is regulated in the European Union is that whether or not these emissions are regulated depends on what you're doing to cause them. If you produce nitric acid or adipic acid, which are the two biggest sources of these emissions, you have to pay for emission certificates. However, the third most important chemical causing these emissions, caprolactam, is not covered by the emission trading system. These emissions are not regulated. It seems that there was a decision made that they covered the largest emission sources and the smaller ones they didn't consider as important enough to cover. Nevertheless, it is a bit odd. Despite that these emissions are essentially unregulated, most factories within Europe still are avoiding these emissions, and some progress has been made in recent years. As you can see here, again, the blue line is the European Union. You can see that the emissions have been going down very rapidly since around the last 10 years. This was mostly driven by the fact that two factories, one in the Netherlands and one in Belgium, which you can also see these curves here, which were among the largest factories producing this caprolactam, were installing technology to avoid these emissions. Here's a picture from a factory in Belgium, so you can see how such an emission avoidance plant looks. Right now there's a situation where the chemical industry in general is in a relatively difficult situation due to overcapacities, due to high energy prices. And many of these caprolactam factories in Europe that are relatively clean, that have very low emissions, are either shutting down or are in danger. This picture is from the company Domo in Germany. They report basically no N2O emissions from this factory. And they filed for insolvency last year, and it's currently uncertain what's going to happen with this factory. You may wonder, given that these factories are already very clean, shouldn't there be policy that supports them, that makes sure that they are not replaced by other factories that are dirtier? And that's something I have asked myself and I have covered recently in a newsletter. And I'll put a link to that in the description, so if you want to read about that in detail, click on that link. I already covered N2O emissions twice in my newsletter. I will link both articles in the description. If you enjoyed this video, I would of course appreciate if you like it or if you subscribe to the channel. And if you have any questions or comments, please leave a comment. And also, I have covered the topic of N2O emissions already twice in my newsletter. I will link both old newsletters in the description. If you're more generally interested in the topic of powerful, let's say unusual greenhouse gases, I recently also made a video about SF6, which is another very powerful greenhouse gas. Of course, I will also put a link to that in the description.